Hello everyone, good morning to all of you. Myself Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today in this lecture, I am going to discuss about the solutions of question bank from Module 5 from Vector Calculus. In this lecture, I want to discuss about part C, definition and short answer type question. So here I want to discuss about some definitions and some short answer type questions. Okay. So first of all, I want to suggest two references of test books. First reference of test book, the name of the authors are N.P. Wali and Dr. Manish Goyal. Publications is Lakshmi Publication Private Limited. Second reference of test book, the name of the authors are H.K. Das and Dr. Rama Verma. Publications S. Chand and Company Private Limited. So, in this lecture, I am going to discuss about the solutions of question bank from Module 5 and from Vector Calculus. Now I want to discuss a part C from Module 5, definitions and short answer type questions. Here I want to discuss on this topic. First question 1. Prove that f vector f point function is given in this question. Yzi is unit vector along x-axis plus zx, j is unit vector along y-axis plus xy and k is unit vector along z-axis. So f vector is the vector point function is given in this question, and we have to prove that this vector point function is a rotational vector. Okay. So this is short answer type questions from part C. So I want to prove it. Okay. So solution. Given us that vector point function f, this is equal to yzi and plus zxj and plus xyk. Okay, this equation 1 is given. Vector point function is given in this question. Now vector is a rotational vector. If vector is a irrotational vector, then the condition is, condition del cross vector f, this must be equal to 0. This is equation 2. Okay, del cross f. In rotational vector, if vector is irrotational, then del cross f equal to 0 or curl f equal to 0. Or we can say curl f equal to 0. This implies that del cross f equal to 0. This implies, so here LHS, T LHS here, del cross f, this equal to here determinate I cap, j cap, k cap, dou over dou x, dou over dou y, dou over dou z. Here yz, zx and xy. Okay, yz, zx, xy. Now solving this here. So del cross f, this is equal to I in bracket. First row and first column is cancelled. First row and first column is cancelled. So dou over dou y of xy minus dou over dou z of yz and minus j in bracket, second column and first row cancel. So dou over dou x of xy minus dou over dou z of yz. Okay. Next is plus k. Here k cap. First row and third column is cancelled. First row and third column is cancelled. Then we get here dou over dou x of zx minus dou over dou y yz. Okay. After differentiating here, we get here del cross f. This equal to here I. In this bracket, differentiating with respect to y to xy. So x is constant with respect to y. So x taking out here. Dou over dou y of y. And minus here differentiating yz with respect to z. So y is constant. Dou over dou z of z. Minus j. Here differentiating xy with respect to x. So y is constant. Dou over dou x of x. Minus here yz. Here is minus sign. Minus sign. So differentiating yz with respect to z. So y is constant. Dou over dou z of here z. Now plus k in bracket. Here differentiating of x with respect to x, zx. Z is constant. Dou over dou x of x. And minus. Here differentiating of yz with respect to y. So z is constant. Dou over dou y of here y. Clear? So we get here del cross f, this equal to I. In bracket, here this 1, x into 1, y into 1. So x minus y. X into 1 and y into 1. Here x and here is y. X and here this cancel. Dou over dou y of xy. Dou over dou z of zx. So here zx. Here is wrong. Here is zx. So here x is common. Okay. Dou over dou x. J cancel. Dou over dou x of xy. Dou over dou z of yz. So here y. That is correct. Z. So here is x minus x. And minus j. J is here j. Y minus y. And plus k. Z minus z. So we get here del cross f, function f, this equal to 0. This cancel to this cancel to this cancel to this. So del cross f equal to 0 here. This one. So now, here we know del cross f, this equal to I and here x minus x minus j, y minus y and here minus k, z minus z. So we see that this cancel to this cancel to this cancel. So I into 0 minus j into 0 and k into 0. So we get here 0. del cross F equal to 0. So LHS equal to RHS means del cross F equal to 0. Show the given vector point function F YZ I plus ZX J plus XY K is a irrotational vector. Rotational vector, okay? Proved. Irrotational vector. Now problem 2, question 2. Write the statement of Green theorem and explain it. There are three theorems which are very important. First is Gauss divergence theorem, second is Green theorem, and third is Stokes theorem. So the statement of each theorem should be remembered 100% because the statement of these theorems are very important. So in short question, we are getting in this question the short answer type question, write the statement of Green theorem and explain it. So here solution. Statement of Green theorems. Green theorem. Statement of Green theorem is line integral equal to area integral. Line integral equal to area integral. Line integral C m dx plus n dy. And this equal to double integration, this is region R, dou n over dou x minus dou m over dou y and dx dy. Okay, dx into dy. This is a statement of Green theorem. Here is line integrals. Okay, so here is in this theorem, here f is a vector point function. Vector point function is m I cap n plus n j cap, and our vector point function is xi plus yj and plus zk. So now dr vector is dxi plus dyj and plus dzk. So now here line integral C vector f dot dr. This is equal to, we write here double integration r and here dou n over dou x minus dou m over dou y and into dx dy. So now here integration C f vector mi plus nj, this is two dimension vector, and into dot dxi plus dyj and plus dzk. This equal to integration region R dou n over dou x minus dou m over dou y and dx into dy. So now integration C dot product to this dot product. So I to I, j to j, k to k. So here we get I dot I this equal to 1, j dot j, this equal to 1, k dot k, this equal to 1, and I dot j, this equal to 0, j dot k, this equal to 0, and k dot I, this equal to 0. Okay, so we get here m dx plus n dy and plus 0. Here is not k, so this result is 0. So this equal to double integration r dou n over dou x and dou m over dou y. This is dx into dy. I am not giving here proof of Green theorem. I am writing only formula of Green theorem which we apply in the question. Okay, left hand side and right hand side. So this is the basic, this is the statement of Green theorem. Line integral equal to regional integral, area integral. Okay. Next, question 3. State Gauss divergence theorem or transformation between surface integral and volume integral and explain it. So this is the first theorem, Gauss divergence theorem, and this is the relation between surface integral equal to volume integral. So solution here. Gauss divergence theorem. Gauss divergence theorem. Gauss divergence theorem statement. Statement. Here surface integral equal to volume integral. Surface integral, double integration, surface, f is any vector point function, dot n is unit normal vector, n is a unit normal vector perpendicular to the surface, n into ds. This is equal to triple integration, here is volume, divergence f dv. This is formula, divergence f dv. So here n is a unit normal vector, which is perpendicular to the given surface S outwards. Okay, and f is a vector point function which is the position vector inside the given surface. Okay, so now here this is the volume B. Here writing any P point. This is the small volume dV, and here is the surface. This is the ds. ds is any surface, n is the normal vector which is perpendicular to this. Vector. N is the normal vector perpendicular to this. normal vector. So in this is total volume is V. dV is elementary volume of a point. ds is the elementary surface. So here we write the formula. Here we write the formula double integration s. Here f vector dot n and ds. This equal to triple integration v divergence f n into dv. So this is known as a Gauss divergence formula, Gauss divergence theorem. This is surface integral, this is volume integral. Surface integral and equal to volume integral. Okay. Now next. Show that, next problem 4. Show that, this is very short problem, short answer type question from part C in vector calculus and module 5. So that del cross del phi equal to 0, where phi is a scalar point function. So solution, phi given us that phi is a scalar point function. Scalar point function. And we are to prove here, del cross del of phi, this equal to 0. So LHS del cross del of phi. So del means I dou over dou x plus j dou over dou y and plus k dou over dou z. This is the del. And cross dou phi cross I dou phi. Phi is scalar point function. So dou over here dou x plus j dou over dou y plus k dou over dou z and into phi. Okay. So now we can write this function del cross del phi, this equal to dou over dou x I and plus j dou over dou y plus k dou over dou z and cross here I dou phi over dou x and plus j dou phi over dou y and plus k dou phi over dou z. Now writing this equal to here del cross del phi. So we can write this here determinate I, j and k. So here dou over dou x, dou over dou y, dou over dou z, dou phi over dou x, dou phi over dou y, dou phi over dou z. Now opening this. After opening this I and here, cancel first row and first column. This. So we write here dou 2 phi over dou y dou z. This multiply to this. So dou 2 phi over dou y dou z minus dou 2 phi dou z dou y. This cancel minus j cap. So here this cancel j, second row minus j. So dou 2x phi dou x dou z minus dou 2 phi dou z dou x plus k. This cancel this. So dou 2x phi dou x dou y minus dou 2 phi dou y dou x. What we know that by partial differentiation, by partial differentiation dou 2 phi over dou x dou y, this equal to dou 2 phi dou y dou x. This is same. This is the property of partial. This is the property of partial differentiation. Partial differentiation. Property of partial differentiation. And dou 2 phi over dou y dou z, this equal to dou 2 phi dou z dou y. And dou 2 phi over dou z dou x equal to dou 2 phi dou x dou z. These are the property of partial which are equal to each other. So we can write here del cross del phi, this equal to I. So this is, both are same. So del 2 phi over del y del z minus dou 2 phi del z del y minus j dou 2 phi dou x dou z minus dou 2 phi dou z dou x plus k here dou 2 phi z is cancelled. So dou 2 phi dou x dou y and minus dou 2 phi dou y dou x. So this is same. This cancel to this cancel to this cancel to. We have given these are equals. So del cross del phi, this equal to I 0 minus j 0 plus k 0. So total result 0. So we can say here del cross del phi equal to 0, where phi is a vector point, scalar point function. Next problem is question 5. If A vector is this and B is this, then find this. Solution. A vector given us that vector A, this equal to 5t square plus ti, 5t square I and plus tj and minus t cube k. This equation 1. B vector is sin ti and minus cos tj. This equation 2. We find the value of finding d over dt differentiating with respect to t of A dot B, vector A dot B vector. This is find, okay, sign of interrogation. First of all, finding A vector dot B vector. A vector dot B vector. So A vector is 5t square plus t, 5t square I plus t j, and next minus t cube k, and dot product here sin ti and minus cos tj. So now here multiply I to I, here multiply I dot I, this is 1, I dot j, this is 1, k dot k, this is 1. So now here I dot I, here 5t square and sin t, 5t square and sin t. minus t cos t and plus 0. There is no k. In second vector, there is no k vector, 0 k vector. So this is a dot b. Now, differentiating this equation, this is 3 and this is 4. This equation 4. Differentiating with respect to t to equation 4 on both sides. On both sides. So d over dt of a vector dot b vector, this equal to d over dt of here 5t square sin t and minus d over dt of t cos t. So here apply product formula in this function. So 5 is common, differentiating t square. T square is constant, d over dt of sin t and plus sin t is constant, d over dt of t square and minus t is constant, d over dt of cos t and plus cos t, d over dt of t. Okay. So we get here 5, this is d over dt. So we get here d over dt of a vector dot b vector and this equal to 5 in bracket. We get here t square sin t, the differentiation of sin t is cos t. T square cos t and plus differentiation of t square is 2t. So sin t into 2t. Okay. D over dt of t square is 2t. Plus minus sign here. Minus sign. So here t differentiation of cos t is minus sin t. Differentiation of cos t is minus sin t and t is 1 plus cos t into 1. D over dt of cos t is minus sin t. Okay. So now this is 5. Here is t square cos t and plus 2t sin t and minus plus t sin t and minus cos t. Okay. So this equal to here cos t is common. So writing here 5t square minus 1, or we can write this type 5t square cos t and minus cos t plus 2t sin t and plus t sin t. So final answer is cos t is common 5t square minus 1 and plus sin t is common 2t plus t. So final result here 5t square minus 1 into cos t and plus 3t sin t. So this is the d over dt of vector a dot b vector. Okay. So this is answer. Now last question 6 here, problem 6. Write the statement of Stokes theorem and explain it. So solution, statement of Stokes theorem. Stokes theorem. So the formula of Stokes theorem is given as, here is line integral equal to line integral equal to surface integral. Surface integral. Line integral equal to surface integral. So here is line integral C f vector and dot f vector dot dr vector. This is three-dimensional, equal to integration, double integration, curl f dot n vector into ds. This is the formula. Formula of Green theorem, where f is, vector f is f1 I cap plus f2 j cap and plus f3 k cap, and n vector is cos alpha I plus cos beta j and plus cos gamma k. Okay, this is n vector. N is unit normal vector which is perpendicular to the surface. Surface is this. This is the surface. This is point on surface, ds, elementary point. N is normal vector to the perpendicular to the surface. Okay. F is point, vector point function is given here. And R is vector here, xi plus yj and plus zk. Dr vector is dxi vector plus dyj vector and plus dzk vector. Okay. This is equation 1, this is 2, this 3 and this 4 and this equation is 5. So now, first of all, finding f vector dot dr vector. So this equal to here f1 I plus f2 j plus f3 k and dot dxi plus dyj and plus dzk. So now finally f1 dx plus f2 dy plus f3 dz. This equation number 5. 6. This is 6. Okay. Now curl f. Finding curl f. Curl f is del cross f. So this is y vector. Here is I, here is j, here is k. Dou over dou x, dou over dou y and dou over dou z. So now here writing f1, f2, f3. After open this, curl f. Curl f vector equal to del cross vector f. This equal to I here. I, this cancel first column and first row. So here dou f3 over dou y minus dou f2 over dou z. In first result I, there is no x and no f1. f3 minus f2 minus j. So write here second column, first row. So here dou over dou x f3 and minus dou over dou z f1 f1 3 2 2 1 3 2 and 3 1 3 2 and 3 1. Next is plus k. Here is third column and first row cancel. Dou over dou x of f2 minus dou over dou y of f1. 3 2 3 1 2 1. So here finally we get here del cross f. Okay. So we write final formula del cross f curl f dot n or del cross f dot n. Then we get here I. Here is cos alpha and in bracket dou f3 over dou y minus dou f2 over dou z and plus cos beta. Here is dou f1 over dou z minus dou f3 over dou x. Here taking minus inside bracket. This minus writing inside bracket. So sign is opposite. So I am writing dou f1 over dou z first and dou f3 over dou z is last. Plus cos gamma. Cos gamma is here. Cos gamma is here. This writing dou f2 over dou x minus dou f1 over dou y. Okay. So now final answer is integration line integral c f1 dx plus f2 dy and plus f3 dz, and this equal to here double integration, and here s is surface, last one is there is surface. So now here writing surface and writing this here ds cos alpha, here dou f3 over dou y minus dou f2 over dou z and plus cos beta, here dou f1 cos beta dou f1 over dou z minus dou f3 over dou x and plus cos gamma, and here dou f2 over dou x minus dou f1 over dou z and into ds. Okay. So this is the formula. This is in scalar form. This formula, this formula of Stokes theorem is in scalar form. Okay. Equation 1 is given in vector form and this formula is known as a scalar form. So left hand side and right hand side both are equal, then we can say that Stokes theorems are verified for any vector point function in any given surface. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.